Hello again, physics students. Dr. Brinzi here. Sorry for the interruption in the video, and sorry for having to split it into two parts. For some reason, it paused right in the middle of my video, and I had no idea where I paused it. So I have to make a second video to finish this thing off. We just figured out that the acceleration of these two cars as they come to a stop is negative 7.55 meters per second squared. So what I can do is I can plug that back into this equation, and I get 0 equals v sub a minus 7.55 times t. I want to figure out what v sub a is so that I can find out what v sub b is, but this t is still in the way. In other words, I don't know how long it took for these two cars to come to a stop. So let's bring that information to a new slide since I ran out of room there. And it looks like what I'll need to do is I'll need to bring the displacement equation in, because I do know how far the two skidded to a stop. So let's see if that gives us our time. So what I'm just doing here in this first step is just plugging in what I know. I replace VI with VA, which is the velocity just after the collision happened, and replacing A with negative 7.55, and replacing my distance with 25. Now it looks like I'm going to get a quadratic equation in T, and I could use the quadratic formula, except I have a V sub A here, and that thing will not give me a good answer for what t is going to be. So it looks like I'm stuck here and I'm stuck here. But this is also something that I can rewrite as v sub a equals 7.55 t. After all, if I take this minus this, it has to equal 0, right? So this has to equal positive 7.55 t. Well, let's replace v sub a with 7.55 t in our displacement equation right here. When I do that and do a little simplifying, I get on the right hand side 7.55 t squared minus 3.77 t squared. Those are like terms, so I can combine them, and it turns out when you combine them you end up with 3.77 t squared. Then we can divide both sides by 3.77 and find out that t squared is 6.63, or that our time equals 2.58 seconds. So it's going to take 2.58 seconds for those two cars to skid to a stop. Now that I know the time that took them to skid to a stop, let's plug the time back in here to find out what their velocity was when they started skidding. And when I do that, the velocity just after the collision is 19.44 meters per second. But I want to find the velocity before the collision, VB. So let's go back to my momentum equation and plug in 19.44 for V sub A. And let's simplify it by dividing both sides by 1600. And when I do that, I get velocity before the collision of 35.24 meters per second. So that's how fast the car was going before the collision. All right, that took a long time, and it was a lot of steps, wasn't it? But these are all steps that you have been able to manage in the past. You just haven't had to put them together like this. Because there's stuff we had to pull from Unit 1, there's stuff we had to pull from Unit 2 in order to solve this problem. But this is what accident investigators do in real life. I mean, this is a realistic real-life problem. So it's also kind of a hard one unless you have practiced it enough and really know what you're doing. Anyway, that's problem number 7 for, I think it was lesson 4.1.4. And again, if you're running out of time, or if you have a lot of medium level problems to do, I would do those first. before I would try to study this problem. But if this is what you have left, then this is what you have left. All right. Sorry for that awkward ending there, and look forward to seeing you tomorrow, and good luck on the summative. Bye.